Welcome to week 5 of Math 101. That's just a quick overview video for you. So this week you will work on investment problems that use the compound process. When interest is compounded, it means it is computed periodically and added to the account. This interest is now earning interest in addition to the initial deposit. Loans can also have interest computed periodically in this manner. Chapter 10, when we work face-to-face on campus, it flows nicely to discuss the examples from Section 1 and then Section 3. So my suggestion is to first look at Chapter 10, Section 1, at those examples there, and then at Chapter 10, Section 3. The logic is, in Chapter 10, Section 1, you're going forward in time with an initial deposit and then computing the amount at the end of it. In Section 3, it's just the opposite. If you're planning for a future purchase and you know how much you need, well, work backwards to figure out how much you have to deposit now, right, at the start of the investment. We call that the present value, in one lump sum so that it can earn interest and grow to meet the future need. So that's Section 3. Chapter 10, Section 2 has some special tables. These special tables make the process a little easier, but the formulas that we'll discuss in a minute, the formulas that are in this chapter, can also be done with compounding that is daily. So that would be 365 times per year. You're earning interest and having it added into the account. There's a lot of vocabulary in this section. The future value or maturity value is the value at the end of an investment time frame. The principal or the present value is the amount that you deposit at the beginning, or sometimes the amount of a loan being made. Compounding, again, that just means that the interest is computed periodically and added into the account. Compounding can be done several different ways. It can be done annually, which means once per year. It can be done semi-annually, which is twice per year. It can be done quarterly, which is 4 times per year. And if you just let your mind wander a little bit and think about it, well, it could be done once a month. Well, there's 12 months in a year, so that would be 12 times a year. If it's done every week, how many weeks are in a year? 52 weeks in a year, so that would be 52 times a year. And then, as we alluded to a few minutes ago, daily compounding is done every day, so that's 365 days a year. And yes, I know somebody's thinking it, if it's a leap year, right, 366. So I have a little table for you if you print the transcript for this video. But if you have your e-text open or you have your textbook out in front of you, page 375 at the bottom of the page has the listing of semi-annual, annual, and quarterly. And it's also showing you at the very bottom here the adjustment that you do based on the compounding. So we take our annual rate and we divide it by the compounding frequency, and that will tell us the periodic rate. The total number of compounding periods would be the number of years times the compounding frequency. So we need these adjusted periodic rate and total number of periods to plug into our formula or to go to our table. So we have the formula on page 376. And right here in the middle of the page is the basic formula for compound interest. So you did see this formula quickly in chapter 4 with that section that had an overview of some formulas. So hopefully everybody got a good practice run with it there. So here, the I is a little bigger, but you can also open it up yourself, but just making it a little bigger for you. The lowercase I in the formula here is the periodic rate. And the periodic rate is the interest rate per year divided by the number of compounding periods that are in a year. So that's listed right below the little table. Lowercase n is the total number of compounding periods. So that would be the number of compounding periods per year times the number of years. The big I here is interest. So if we know the maturity value, M, the amount in the account at the end of the compounding periods, the end of the investment time, all we have to do is subtract the initial deposit, the principal, to figure out how much interest was earned in total over the entire period. Remember, the interest is being computed and put into the account multiple times. So then to get this total interest value for the investment, we do this M minus P process. The first two examples in this section, chapter 10, section 1, actually have you do it by hand instead of using this formula. This is a nice way to link the concepts of chapter 9 and chapter 10, that you look at each compounding period and the rate in that period, and you do a little computation and you add it in and get your new principal for the next period going forward. And then you compute the interest and you add it in and you get your new P for the next period going forward. That's good to do, and it's good to help you conceptually, but most of the problems will be done using either the formula or a shortcut computation for the formula that uses the tables provided in the book. You can also use the time value of money keys if you purchase the Texas Instruments BA2 Plus calculator. There are some help pages throughout this chapter and a support document provided for you in the Google Share folder for that time value of money features on the calculator. So before I get to the rest of this overview, oops, where'd it go? 377. I went 2 pages too far. Sorry. These are what the tables look like. The compound interest table has periodic rate. Notice that it says interest rate per compounding period at the top and total number of periods along the side. So these values in the table will be that exponential portion of the formula, that 1 plus little I all raised to the n. That's the value you're getting from the table here, that exponential portion. So all you do to find the maturity value is take the principal times the value in the table. Likewise, when you get to chapter 10, section 3, it will be the same process. You're going to get the table value and it will be your exponential portion of the formula. And all you have to do then is multiply it by your desired future value to compute that starting value that we'll be needing. So here is example 4, starting on the bottom of page 376, and it will go up to page 377. Have a 7% interest rate that says compounded semi-annually. We have an initial deposit or principal of $4,500. We're going to use the formula to find the compound amount after 5 years, so our time is given here. And then we're going to do that subtraction, M minus P, to get our interest. We have to find our periodic rate, so we take our 7% divided by the compounding frequency. Semi-annually means 2 times per year. The 7% divided by 2 is 3.5%. Semi-annually, right? Every 6 months for 5 years. So that means it's being done twice every year for a total of 5 times 2 or 10 periods, 10 compounding periods. We plug the 3.5% into our formula as 0.035. And on your calculator, you want to be careful to do the exponent key. That's a generic key. Don't just click, the little x squared key. You want to click the exponent key. So this is something, if you're struggling with it, I do have a exponents document that's linked in the transcript for the video. Plus, if you're just going through the Google Share folder, it's in the Google Share folder. Also, if you look on page 377 in the textbook, there's a little list of the calculator settings to do. There's also a link for you in the transcript and in our course website to several videos and information on how to use the time value of money keys on the calculator. You could opt to use that as well. In the discussions, you should talk about how you did your computation, because there's more than one approach to it. And if anybody's struggling and not getting the right answers going through the examples, then the discussion is a great place to talk about those details of how you plugged it into your calculator. Which method did you do? When did you click this key? Oh, don't forget the parentheses, things of that nature. And it will also help us identify if anybody has a setting on their calculator that's getting in the way of the computation. And then the last step for this example was how much interest was earned. Once we know the compound amount, we subtract the starting value to get the interest earned. The difference between what you started with and what you ended with will be the interest that the bank put in. Okay, just 1 minute here. Chapter 10, Section 3. There is a little derivation here. I'm on page 394. There is a little derivation here right in the middle talking about a little bit of algebra here. In order to solve for the present value or the starting principal that needs to be deposited to get a specified future value, a maturity value at the end, And all you're going to do is divide both sides by 1 plus I raised to the n. There's your formula now for present value. If you're doing the computation by hand, then you're dividing by that 1 plus I raised to the n. That's shown here at the bottom of page 394. I just want to point out, if you're using the tables, notice here in example 1 that they multiplied. So the table values in chapter 10, section 3 represent 1 over 1 plus I raised to the n. So that means you will do the same pattern that you did in chapter 10, section 1. And as you will see, the same pattern in chapter 10, section 2, chapter 10, section 3, and in chapter 11. You take that value times the table value. So the table value here has been adjusted already. So it's 1 over this exponential value. So that all you have to do is multiply by your principal. But if you're typing it in your calculator and doing it by hand, then it would be that desired future value divided by the exponential portion. All right, so that brings us up to what are you doing in week 5? That's your quick overview of the type of problems you're seeing. You should be reading chapter 10, study those examples, complete the assigned problems. There are several learning resources in your Google Share folder. You can either go to the Google Share folder and scroll to find them, or I put links for you in the transcript document if you're looking at the transcript document. You have several chapter 10 examples here, files for you to look at. The exponents on the Windows calculator is also a helpful document that is posted here in the Google Share folder. And there's a document for calculating the days and dates on the Windows calculator. So that can come in handy when you look at chapter 10, section 2, which is all the same process, just for daily compounding. So your lessons in my math lab for participation, we'll walk through some more examples for you. And you also may opt to click into the time value of money examples right here at the end of the first paragraph here for week 5. If you want to go through this document, if you bought the Texas Instruments BA2 Plus calculator or had it from a different class, then this gives you a list of links for how to use that time value of money feature and a little bit of explanation. So there's more than one way to correctly get it to compute these problems. And you can also use it to compute the annuities in chapter 11. So this is some support for you if you're doing the time value of money keys on the calculator. Also in week 5, there will be a discussion like in every other week. You want to submit 2 problems, make them detailed, give explanations, discuss the process you took and how you did your computations. My other little tip is to clearly label each value. Right? We're talking maturity values, we're talking present values, the rates, the periodic rates, the compounding frequency. There's a lot more going on now. So if you are labeling everything clearly, it's going to help you and it's going to help others. Please strive to be active more than one day. I know I've communicated with a few people and there's a lot still going on. I'm glad our quarantining is finally lifting, but I know there's still a lot going on. And if you can be active more than one day, it makes the discussion a better learning experience. But please do the best that you can and keep in mind that once it closes, you can still go in it for reading and viewing. You just can't post anymore. So it's still a good study tool for you even after the fact. All right, so with that as our last reminder, we're finishing up with the week 4 discussion as well. It will remain open this week. So take a quick look at that. Make sure that you don't need to post any corrections or additions, any interactivity posts. A few of you have commented on using some YouTube videos. If you're finding any specific videos helpful, post a note for your classmates as to what you found and what you're using and a link for them. That's a great interactivity post as well. So also this week is your second quiz. Keep in mind that you can pause the quiz. You have the save for later option, but you have to work the problem that's on the screen in front of you. And instead of going to the next problem, then you can do the save for later at that point. You have the quiz references questions here, so you can take a look at what to expect and decide, okay, I'm going to do all the chapter 8 problems, then I'm going to pause it. Then I'm going to do the chapter 9 problems. You have your choice to pause it more than once. And then you also have the ability to do the entire quiz more than once. So you can do the pausing, that's separate from an attempt. You can pause it more than once, and then once that first try is completely submitted, then you review it using the review mode in the MyMathLab gradebook and study as you need, then give it a second try for a better grade if you can. So it will be open this week. Everybody should at least try it once this week, and then it remains open a second week so that you can do some reviewing and give it a second try for a better grade. No worries, only the best score is the one that counts. So there is that Help Me Solve feature. When you're going into the MyMathLab gradebook, click on Question Help. There's feedback. If I've inserted comments for a graded quiz, then it's there. And there's the Help Me Solve tutorial for you to work with as a self-help tool. I do want to point out one other resource now that we are past the halfway point. In the document sharing section, I just want to point out these two review cards here, the basic review card and the business math review card. So you have a basic math review card, does a couple different topics and some algebra and some geometry. And then the business math review card is nice because it has all these formulas. Nice reminder of place value and rounding, but it has all the formulas that you're working with in these chapters so far. So if it's starting to feel like you have a lot that you're trying to remember, you print off these cards and stick them with your notebook, and they're great for quick references. Okay, so that is the end of your week 5 walkthrough. I will post the transcript and the video for you, and I look forward to working with you online. My office hours will again be this Thursday. Feel free to drop in or email me, inbox message me anytime with questions. Take care.